Let me switch this. Wow. Hey everyone, my name is Brandon Harrison. I am a game developer at Working Man Interactive, also Bread Machine Games. I know a bunch of you in the room, a lot of familiar faces. Thank you for coming. A little short bio about me. I'm coming on to about 3 years at Working Man and Bread Machine as a gameplay developer. I'm currently a lead gameplay developer on a 2D mobile game that's unannounced right now. I also do streaming for Bread Machine Games. We stream on Twitch Tuesday, Wednesday, and Friday every week. About 3 years there. Previously worked with PHL Collective and PGL in Philadelphia before that. So been in Rochester for about 3 years now. So we're going to piggyback off of Noel's talk last month about using Spine. Last talk was a very art and animator heavy discussion, maybe not heavy discussion, but introduction to what Spine is as a tool. And I'm going to go on and talk a little bit about how I use it in my day-to-day job, which is bringing in those assets to Unity and using that inside of the Unity engine. So one thing to note about Spine is they have a lot of runtimes. So if we just go to their runtime page here, if you're interested in Spine, you don't need to be using it in Unity. It's just what we use it in. But it's supported in a lot of different game making frameworks. So if you guys are interested or currently use things like, XNA, or if you're just doing stuff in HTML5, you can still use Spine. Export is all supported. And it's very easy. You can just grab these runtimes off of their official page. They make it very easy, especially if you don't want to purchase the Spine software. It's still very easy. They give you a lot of examples to get off and running, and that's what we're going to kind of look at today is some of the examples that they supply on their website, and then a couple other things that we have. So again, we're focusing on Unity today because that's what I currently use it in my day-to-day. But again, you can use it in a lot of different things. Flash, you've got Objective-C frameworks, Lua, all that stuff. So you can download all these runtimes right off of their page. So we're just going to jump in. We're going to take a look at a couple examples that they supply. So I'm using Unity 2017 right now. They provide a lot of example files, right? If we go into Spine examples in Spine, there's a lot of stuff in here. These are already imported assets. So if we look at the folder structure in here, it's kind of hard to see on that wall over there, but we have a couple different things. We have the imported assets and then the generated assets. The generated assets are things like Unity materials, the skeleton data that's generated, and of course the PNG sheets that the Spine software uses, right? If we want to, after importing this into Unity, they make it extremely simple. We can just grab this skeleton data that's generated down here and drag it into the hierarchy. We have an option of creating an animation versus a graphic. I'll get into that later. But right now we just want to click animation. We have our asset in the scene already. It's set to its setup pose. Again, very easy as long as the import goes well, and it would definitely tell you if it didn't. You can basically just drag and drop into the scene totally fine. We can take a look at this dragon skeleton data. This guy's pretty cool. So these are all animations and sprites created in Esoteric's Spine software. If we take a look at some of the inspector properties that are exposed here, we have a lot of good stuff. It's going to attach this skeleton animation script to it. We have the skin, which with this guy, he only has one skin set up in Spine. If you don't know about skins, you can go back and take a look at Noelle's workshop, where I think that she talked about creating different skins. Sorting layer is very important if you for rendering to the cameras, especially if you're doing UI stuff with canvases. And kind of where it gets into some nitty-gritty stuff down here is we have, we're looking at look at Spine Boy. We have a list of animations over here. If we set this property in the inspector right now, it's just going to be kind of initialized. So if we set to death, we hit play, he's going to play his animation. Oh, he's dead. Right. But sometimes you want to initialize and switch animations in script, probably all the time. So we're just going to set that back down to none. We can also change the time scale here pretty easily. If we want to slow down time, speed it up, very easy. Which you probably can't even see that. So that stuff's pretty, the object itself is pretty simple. There's not a whole lot in here. You can get into the advanced features, which is basically setting initial values for flipping, a couple different mesh values. You don't have to get too much into that. Something else that's super useful is looking at this skeleton data that's generated when you do import these resources. This is where you're going to be able to take a look at and preview a lot of the animations. So we're taking a look over here on the side, these animations over here. We can preview the death animation, hoverboard, idle, all this stuff. And as always, you can check the setup pose, which is really important for mixing between animations and resetting a lot of slots and attachments. Something else that's super useful for a developer to know about with Spine, it's hard to get the names of a lot of attachments and slots that we set up in Unity or in Spine. So right here in the skeleton data, we can go down to slots and we can check out all of the slots that are set up on this animation rig. We have parts of the gun, the muzzle, portal flare, the goggles, body parts, all of this stuff. And if we want to go even deeper, we can take a look at all of the attachments on all of these as well. We'll get into a little bit with this in a bit, but it's extremely useful to reference the names of these attachments and the names of these slots when you start using it in code, because they don't immediately make it the easiest thing to do to print out a list of attachments and slots. You can do it, it's just kind of not that easy. So like I said, it's extremely easy to just drag and drop these skeleton datas into the scene. It's going to generate objects. And what we do to import to Unity, I'll show in a little bit, but you're going to have your export from Spine, which is going to have a JSON, an Atlas, and a PNG file, or a bunch of PNG files. If we just drag all of those required assets into Unity, it's going to generate these files. And it's going to be very easy to just drag and drop into here. So now we have two. Cool. Before we jump into a little bit of code, there's a couple preferences that are kind of important. They have a cool little, where's preferences? I always forget. There we go. If you have the Spine runtime included in your Unity, you'll get a preference window for Spine down here. A lot of this stuff you can kind of fiddle around with and see what works for you. the major things are the default mix, the default skeleton data scale. Now, what the default skeleton data scale is that it's basically deciding the pixels per unit in Unity to how they set it up in the Spine software. So if your artist is working with a default scale inside of Spine and you bring it into Unity, you can actually play with the import scale setting. If we set this to 1, then it's going to be a 1 pixel per Unity unit on import. This is really going to come into play when you start messing around with Unity physics. Usually, if you're not messing with Unity physics in Spine, it's not too big of an issue. You just kind of work with your artist to settle on a scale that works, a resolution that looks good. But the default here, they like to set it at 0.01, which is basically 100 pixels per Unity units. A default mix, this is for animation. If you guys don't know what animation mixing is, it's basically if you have an animation running and you want to run a second animation, it can automatically mix the two animations together to look better. Your artist is definitely going to need to do a little bit of work to make sure that it doesn't conflict when mixing. So the default here is 0.2. If you want it to switch directly into the new animation without lerping any of those values, then you can set that to 0. It's going to look a lot more rigid. But again, you work with your designer to decide how you guys want to set up some of these spine assets. Some of these other things you can kind of play around with. I don't typically mess with. Default shader can be a big one. It really depends on your export settings. Right now, Spine, when importing into Unity, assumes that you're exporting with pre-multiplied alpha. If you don't do that, which is an option, you want to be using a different shader, which is going to display the alpha correctly. But these all look like they were exported with pre-multiply alpha on, so that's totally fine. Cool. What else do we got? As I said before, when you drag and drop this into the hierarchy, you have some options here. Skeleton animation is typically what you're going to be using. If you are going to be using Spine in UI, what we do at Working Man is we like to make UI buttons out of Spine. That way the animators can animate really juicy click animations instead of just kind of tweening down and up. It kind of makes a polishy difference. If we add some UI here, like a canvas, if we're ever adding Spine to a UI canvas, we want to use the skeleton graphic, which is basically going to be setting up to use this on a UI canvas. You can see that this is probably like an overlay, but where are we at? A lot bigger. So if you're ever running canvases with UI and you've got different screen spaces going on, maybe like an overlay for UI, and you want Spine to show up and render correctly on that UI, you want to be using this skeleton graphics, because what they're going to be doing is they're going to be using renderers that are specific to Unity's canvas rendering. Cool. So we can take a little look at skins. I know that the default goblin example here has, you can see, let's take a look. That looks like a really good goblin. It has some skins set up in the spine. The default skin, you can see, doesn't show any body. It's kind of hard to see over there, but what we have is just a shield, a dagger, and a spear. If we set this initial skin, then we're going to see all of the assets that are specific to that skin. We have two skins here. We have Goblin and Goblin Girl, which is a horrible naming convention. You can see that it switches the assets depending on what skin they're using. So when the spine artist is setting up different skins. They're choosing which images to use and swap between. If you guys want to learn more about that, again, go back and watch Noelle's workshop video. She goes through skins. You can see the default here is not using either of those skins. So we have a little bit of control over what we're showing, and skins are nice because you can do lots of the same animations for different images, right? So Goblin and Goblin Girl and Walk and Idle animation are probably exactly the same. The only thing that's different is that they're using different skins, which means they're using different image assets. They look different. So it's saving. Cool. What else do we got? One thing that I don't really have much of an example on is talking about exporting spine for use in Unity. You have a couple different options. You can export using JSON format. You can also export using binary format. I'm sure that we can find export. Cool. So if you're just getting into Spine, I recommend using JSON format. What that's going to do is it's going to create a JSON file that you can, it's going to be in readable text. So if there's anything wrong with the import, you can kind of go check out what's going on in there. You can also pretty print it, which means it's not all on one line. So it's great for Spine beginners. Another option here is you can kind of see right here is we can export the data as binary, which is super nice because that's going to, instead of a JSON, export a .scale. And it's going to be roughly about a quarter of the size of the JSON file. So if you really are going for taking a look at your performance or your optimization, if you're trying to shave off some bytes there, you can definitely export as binary, and it's going to cut down the size of that file basically by 3/4 on average is what I usually see. There's some pros and cons with that. Obviously, the pros are the optimization that the memory that you're gonna save there. The con is that anytime you update your Spine runtime in Unity, you're basically going to need to re-export all of the binary assets. It doesn't get updated with updated runtimes. How often you want to update your Spine runtime can be questionable, especially if you have a live product. But again, if you do update your runtime, you're going to need to re-export the binary asset. Cool. So we can take a look at kind of how to manipulate Spine a bit in code. So I'm going to use this default SpineBoy Pro asset. It's in the Spine examples. You download the runtime, and I have a script here that I wrote that I'm just going to throw onto this SpineBoy. It's called Custom Spine Object. If you guys are interested in checking this out, it's just example code. I can link the repo. It's basically just hosted on my GitHub over here. It's very light. It's just the Spine runtime and all of the examples and this one script if you guys want to check it out. Cool. So we can do a whole bunch of stuff. The main thing that we're going to be operating off of is this skeleton animation object. This basically houses all of the data. It's got the animation states if we want to be setting animations, if we want to be swapping attachments on slots. Anything that we kind of want to manipulate with this skeleton is basically going to be coming off this skeleton animation. It's also the script that is generated and attached to the Spine object here. For ease of access today, I kind of just wrote a couple of the idle and animation names here, as well as some slot names. Cool. So there's a couple things that we want to take a look at. Just immediately, we can supply it with an initial animation to give it an animation, we're going to write skeleton animation or animator dot animation state dot set animation. The animation state is basically all the information about what's going on with the animations. Currently, it takes 3 parameters by default. It takes a track parameter, it takes the animation name, and then a flag whether you want to loop this animation or not. Tracks are pretty interesting. It basically allows you to run multiple animations on a spine object at the same time, especially if you have non-conflicting animations. Say you have a walk animation that only animates the legs of a character, and you have a wave animation that only animates the arms of a character. If those are playing on separate animation tracks, they could, and they're not conflicting in the animation, they're not using the same slots to animate, you can be playing those at the same time, right? So what I do typically is I define some default animation tracks. So if we take a look up here, we have the movement track is always going to be 0, and our action track is always going to be 1. So movement is going to kind of be reserved for any of the walking or jumping or idle animation stuff, and then action track is always going to be for kind of like the shooting or whatever the active animations are. So again, if we're going to just in start set a default animation, we can do that by setting an animation on the animation state. So if we hit play now, without setting any of those exposed properties in the inspector, we can see that he doesn't idle somehow. Let's see if any of this works. Oh, I see. I see what's going on. It's not enabling itself. Great. So we set an initial animation. So he's just sitting here and he's idling. He's doing his idle animation. I could have set that in the inspector, but just for cleanliness sake, I want to keep all of that stuff set to none, just so it's not going to do any unexpected behavior. I want to control all of it in code. So I wrote like a very quick input update method. Basically what's going to happen is we're going to look for inputs based off of the left, right, space keys. And based off of those, we're going to set the animation state. So here I have if input jump, and he's on the ground, or he's not on the ground. If he's on the ground, he's going to animate the jump animation. If we're going left or right, we're going to flip the character just by scaling the X, and then we're going to set the animation to walk. If none of these inputs are firing, we're going to run the idle animation, and that's basically just going to be a very simple walking animation, right? We're hitting left and right. We're setting the different animations. If we don't put anything in there, he's going to idle. If we hit space, he'll do a very weird jump. So that's basically switching animations based off of inputs. It's extremely easy. We're always setting it to that movement track. If we were to set some of these animations to different tracks, then these animations would literally try to animate over top of each other, and you would have like very weird, probably funny results because this skeleton rig is going to be trying to move in multiple different directions at the same time. So we don't want that. Cool. If we want, we can mess with the timescale via code. I don't know if I'm doing that here. That's also pretty easy. Again, it's just something based off of the animation state. So right here, we can just say, skeleton animation state dot timescale. And if we want this to be modified, we can set it to half speed, which means it's going to be animating at half of the frames per second that the animator has set it to. I don't typically mess with timescale unless we're kind of doing effects or something like that. Maybe like on a death, if everything's slowing down, but the world is still at a speed of 1, we can mess with timescale. You can lerp the timescale. So it's used in certain spots, but you try to use it sparingly. Cool. So we talked a little bit about skins earlier. For that goblin animation, again, we can access the skins via code as long as you have the string names of the skins that you want to set. It's really easy. You're basically just telling the animation, the skeleton, to apply whatever skin you want. So for this example, it would be like, we're going to create a goblin spine animation or a goblin spine skeleton, and we want to set the initial skin to the female skin or whatever. It's very easy. All of that stuff is exposed through the skeleton. So we also have easy accessors to animation events, which is very fun. See if this will work, because it wasn't working before. It might have been because it was awake. I don't know. So if we want stuff to fire on animation complete or animation start, say you have an animation that when it starts the animation loop, you want like a particle effect to play, you can grab and hook into those events super easy. Again, we're just going to grab this animation state, and it's got a couple different ones. I'm using the complete event here, and I'm just subscribing to it via this function down here called on animation complete that I created. And for this, if it works correctly, we're going to take a look at what animation is currently playing or what animation just completed and switch based off of that and do some logic. The parameter that these events take is a track entry, because the track entry is going to hold all of the data for the current track animation. So right here we have the parameter p track entry, and we're switching p track entry animation name, right? You can get a couple different things. You can get the time scale, you can get, whatever's playing on that animation track, that data you can find. So here we're just saying if this is equal to the jump animation, we're going to idle. We're going to set to on ground true. And it might not work, but we'll see. Cool, should work. Awesome. So it's looking for the jump animation, and when it's complete, we get that animation event, and we're basically idling now. I don't need to, queue up animations, which I don't typically like to do. I try to stay away from animation queues. I try to let everything be a little bit more animation state and animation event focused. So again, we are hitting space, we're jumping, and that animation on complete event is firing, and we're just going to idle away, and we're going to reset this thing down to the ground, which is super useful. Again, there's other events that you can hook into. There's on start, on complete. There's also on end, which is different from on complete somehow. I'm not sure. Maybe it has something to do with looping. I'm not sure off the top of my head. What else do we got? So we looked a little bit before at some of these skeleton data objects. Spine Boy Pro. If we look at the skeleton data, again, we can see he has a lot of slots in his skeleton for all of the different animating pieces. We have a lot of stuff that is connected to his gun. We can see the actual physical skeleton, like the head and the eyes and the legs, the torso. And we can control basically what images are attached to these if we want. I mean, if you want to literally like grab different images and supply them to this spine rig instead of using the ones that are in the texture packer, you can do that. You can set it to different PNGs and make some really weird monstrosity if you want. So if we look at these attachments on these slots, for example, we'll take a look at goggles. And you can see that it's toggleable. So if we're setting this goggles slot to nothing, he's going to, that image of the goggles is not going to be there. So this stuff is useful. There was a game that we created about like 2 years ago. It was a SpongeBob game, and it was an adventure game. They're picking up lots of items. What we did there was, instead of having real interactions with separate objects in this 2D world, when they interacted with an object, we basically turned on the item slot for their hand, right? If the user went and clicked a rock on the ground, they would walk over to it, and as soon as it finished this animation, we would go in, we would find the palm or hand slot on this animation rig, and we would toggle on the rock PNG or whatever. So now it's following that animation. It's got this image attached to its hand, whatever it is. I think Squidward had a clarinet, because those are Squidward things. I don't know. And all the animations would follow through, and it would have this image attached to its hand. So it's really easy for us to toggle on maybe avatar accessories, right? We do a lot of avatar builders, hats, glasses, shirts, pants, basically just toggling on what these different images are for the skeleton and how it animates. And we can control that in code. So I have what I call a cool button, which I believe is left alt. The cool button is always left alt. And what that is going to do is we have it to toggle the goggles slot, right? So when I press left alt, it's going to toggle the goggles slot attachment between null and the goggles PNG. We could make this be, I don't know, the image of like another head and make it really creepy. But for this sake, we're just going to toggle this off and on. So again, we can grab these slots and these slot attachments in code and set them to what we want them to be. Right here I have a toggle goggles, which is an awesome function name. And what this is basically saying is, on the skeleton, we're going to find the goggles slot, and we're going to check its attachment. If it's null, we're going to set the attachment to the goggles attachment. If it isn't null, we're just going to set it to null. And what that does is that just achieves the effect of setting the attachment during runtime, which is, again, very useful for picking up objects. Again, avatar creator, if they're swiping through what they want their character to wear, each time they press, right arrow key, you can be toggling the attachments of a torso and applying different t-shirts or dresses or whatever you want. So it's super useful to have that ability. And if you notice, like, this is during runtime, so I can toggle this on. It's maintaining its idle animation, right? If I'm walking, all that's happening is it's turning on the PNG for that animated slot, and it's going to follow that animation. It's just whether or not there's an image there or not, right? So we could do this for, like, his head. We could be turning his head off right now, off and on. It's still going to follow that animation during runtime. I think I also have something else. Oh, yeah. Going back to track entries a little bit, kind of an example of playing multiple animations at the same time that don't conflict with each other. Like I said, up top, I have a movement track that's always going to be track entry 0, and an action track that's always going to be track entry 1. So you can play non-conflicting animations over top of each other. So we have this fire animation. This fire animation, oh, I don't want sticky keys because I always do left shift. This is really only animating like the wrist and the gun and the effects, right? So you can tell right now he's idling, and when I hit the fire animation, the idle is not part of that animation. We're playing two animations at the same time, right? If I want to fire at the ground, I can do that. So again, God, I don't want sticky keys now. We can jump, we can fire. Because these animations aren't conflicting with each other, the skeleton rig aren't animating any of these slots at the same time, it looks okay. If it were animating some of these slots at the same time, we would see some weird effects, right? You'd literally have two slots on a skeleton trying to move in two different directions or animate in two different directions. So again, those are kind of where states or track entries are used. And if you kind of work with, working with a spine artist it's a lot of back and forth because, if you guys organize and clean up a lot of these animations in terms of, movement's always only going to be animating this part of the skeleton and the gun's only going to be animating this part of the skeleton, you can enable a whole lot of features just like sticky keys. So those are a little bit about track entries. Cool. We mentioned earlier about default mix for spine. And here we have a 0.2 default mix, animation mix. Again, this is how we want to blend animations into each other. So if we're going from an idle to a walk animation or a walk animation to a jump animation, animation mixing is basically lerping between these two animations and making it look smoother. And you can see the difference if I actually add these mixes manually, which I'm going to turn off real quick. I'm also going to go up here into preferences and make this, I don't know if it's actually going to change it now that it's imported, but we're going to put that to 0. And we're going to look at the difference. It's going to look a lot more rigid. It's going to look a lot more snappier, which maybe you want. So it's a little hard to see here, but going from the idle to the walk animation, it's immediately jumping to the first frame of the walk animation. You can see kind of his back foot is just jumping forward. Jumping into idle doesn't really look natural. You can see that forward foot is just snapping up to where it needs to be for the idle animation. And we can make this look a little bit smoother and a little bit more procedural if we add some animation mixing. So here, we're just going to, again, take this animation state. The mixing is in the data, so we're going to go into the data property and set a mix. We have a to animation, or a from animation and a to animation. So right here, I'm just setting, when we're moving from the idle animation to the walk animation, we're going to mix it by 15%. And we're going to do that going from the walk animation back into the idle animation. We can actually increase this value a little bit to make it a little bit more drastic. So if we set those animation mixes, again, it's going to look a little bit more fluid. I think that your spine artist is going to have to kind of account for some of this stuff if you want it to look really good or maybe not have any issues with animation mixing. So now we can tell a little bit that back foot is sliding into place into that walk animation. When we end our walk animation, the skeleton's going to kind of rest into the idle animation. If we jump, it still doesn't look great, but it's a little bit more fluid. It's lerping those two animation frame values so that we can kind of get to a state over time instead of just snapping into frames, which, again, you know, sometimes you want to have a snappier animation, and it's perfect for that. Other times, if you want to mix it a little bit, mix it up, baby. Something I'm not going to get into incredibly too deep is bounding boxes. I don't think Noelle went over this in her workshop last month, but it's very easy in Spine to draw bounding boxes for a skeleton. So for instance, if we wanted to add a hitbox to Spine Boy here, that was basically just his head, right? What Noelle would do is she would create a bounding box around the Spine Boy's head, and that would animate its translation with all of its animations, right? So in Unity, you wouldn't have to set up like a bounding box to follow anything. You could, I mean, you would, but it'd be a little bit more manual that way, right? So you can grab a bounding box from Spine, you can figure out its vertices, you can add a collider to it, and basically parent it to that object. And now we have bounding boxes that are animating with the character. We don't have static, just giant rectangles or boxes. They can be, you know, polygons of a bunch of different vertices. So that's kind of really nice. I try to stay away from bounding boxes for characters unless they're kind of primitive. What I typically will use them for are for environment set pieces. If we're doing any environment animations in Spine, again, that SpongeBob game, we had animated ocean backgrounds in Spine. We added bounding boxes for colliders on a lot of those environments, so we knew, you know, what we could walk up against and just write some logic there. You know, floors being an obvious one. For the big environments, we also added bounding boxes to enclose the character on screen so they couldn't just walk off the screen forever. I love that. So we can grab bounding boxes via the skeleton. It's a little bit of a deeper dive into the skeleton. What you're going to do is you're going to find basically an array or a list of bounding boxes, and you're going to have to figure out kind of which ones are the ones that you're looking for. It's a little bit deeper down the skeleton data. What we like to do is when we set up a character or something that we're going to reuse a lot, we can just very easily prefab it. So we'll give this a name, Spine Boy Pro. And as long as we just, you know, drag this in, it'll create this prefab. So we can instantiate it during runtime if we really want to. You know, if you want to prefab a Spine enemy and just instantiate and spawn a bunch of enemies or pool them, you can just grab and prefab them. And it's a lot easier to just drag it in, right? Those are prefabs. You guys know what prefabs are. So we went over a whole bunch of stuff, a lot of animation stuff, mixing, attachments, slots, kind of controlling all of that stuff, setting animations, the obvious default kind of basic knowledge for Spine. Animation mixing is really, I love animation mixing. I think it just adds a little bit of polish there. What else? I had something else. Oh, I wanted to go show you guys some. So we talked a bit about exporting in Spine, where you can do it in a JSON data. You can do it in binary data to save space. There's a couple optimization techniques that I'm not going to get into too far, but if you work with your animator or your artist on export techniques, you can save a whole lot of, or you can actually like work to make the export work for you, which say we're creating a lot of characters that share a lot of assets, you know? We're creating characters that have the same arms or the same head type or the same clothing. Instead of creating a whole bunch of skeletons with duplicate assets, we can pack all of those together so that these skeletons are using the same texture pack, for instance. And one thing that we did that for is, let me create a new folder here. Is our Slamland characters. So, can I increase this? No, I can't. So these top 3 files are the JSONs. These are the actual character skeletons. We have our mold dog character, our skeleton character, and our tuber character. These are the JSONs that are spit out. We have one atlas for all of the characters. This is a huge file because we have a lot of different character types and character skins. But instead of exporting an atlas for each character and PNG texture packs for each character, we packed all of those together. So if we take a look at these texture packs, it has the assets for all of our characters because they reuse a lot of stuff. Most notably, we have different colored skin assets in this game. So we might have 4 different skelly characters, 4 different human characters, 4 different spider characters. Those are using the same, you know, glows, backgrounds. You take a look at this. They're using a lot of similar assets, duplicate assets, and we don't want to pack those 4 different times, right? So what we did is we just, in the export settings of Spine, we said combine all of the subdirectories, combine all of the images, and we're going to pack them into one export instead of exporting with each skeleton. So if we grab all of these, we drag this into Unity, it's going to import the spine, and it's going to do what I pointed out in the very beginning. It's going to auto-generate these skeleton datas. So we have that huge atlas. We have the PNGs, right? What was generated is this character's material, which, because we did not export this with pre-multiply alpha, I'm going to change the shader, straight alpha skeleton fill. And we have our 3 skeleton datas for our 3 skeleton or character JSONs: mold dog, skelly, tuber, right? So in a typical export setting, we would export and texture pack images for each skeleton data. Because we're reusing a lot of assets, we just texture packed everything together because it cut down on the number of texture pack sheets. And we still get all of our separate skeleton datas. So if we pull this in, create a skeleton animation, we have mold dog in there. We can add skelly, add tuber, right? Let's give them some animations. Run, loop, jump, squat. So we cut down on the number of texture pack sheets because of this. I guess the middle guy doesn't want to animate, but we got the other guys in there. And that was super useful for us because otherwise we would have had a lot of duplicate assets, which we just don't really want. There's no reason to have them in the project. Cut down on the number of texture packed PNG sheets for us. Cool. So I know that I ran through a whole bunch of material very quickly, but that is pretty much all I have for today. If you guys have any questions or you guys want to see anything in particular, now would be the time. Let me know. Hey.
So you're showing us how you use tracks to have two images recorded at one time. And so if he could fire at any time, his arm might be in a position, right? But he'll fire the gun.
Right.
How would you go about like finding out what the orientation of the gun is? Would you use like the bounding box?
What we could do is we could actually access the bones on the skeleton, as well as the slots, although I'm not sure if slots would give you what you want. What we could do is we could find the bone attached with the slot that is like the wrist or the gun, and we can access that transform's properties and see what world rotation it might be at, local rotation, right? If there's an animation that somehow makes his wrist go past like 90 degrees, and we want to check that local rotation, we would just check the rotation of that bone. To access that, it's kind of going down what I was saying before with skins and stuff. You're going to find all that animation or all that stuff through the skeleton. So if we say skeleton animation dot skeleton, we can check out bones here, right? And what this is going to do is give us a list of bones. If we know what bone we're looking for, we can actually find bones via names, I believe. Brian, can you name bones? Or is it just slots? Yeah. So it's super nice. If you have a wrist bone or whatever, you can just find that literal string and find that bone. And you could get the transform parent of it and just check the rotation. Bounding boxes are more of kind of they're kind of what they sound like. They're just like a bounding box that is going to animate with the character. So if you ever want to, you could check the orientation, right? The rotation of that bounding box. But that's, the way that I use those are for checking maybe like, how do I put this? Maybe like collision, right? If I want to add colliders to it or something. Right. Exactly, right? You add a bounding box to the fist, right? And you have the punch animation. That bounding box is going to animate with that punch animation. So you can track that very easy, right? I believe you can still get like translation properties of bounding boxes. I'm not sure how easy it is. Spine has made it natively to track bounding boxes, but when I was working with bounding boxes like a year ago, I was actually creating 2D colliders, either box colliders or, N vertice colliders, and attaching each vertex to the bounding box vertex and just saying follow the parent, right? So I have a native Unity collider that's following the native spine boundary box. But they're always updating this, so I would assume that they kind of got better about that. Cool.
What about performance versus like spine in Unity versus like animator?
Yeah, you're saying what the performance difference is like versus using spine animation versus Unity animator. It depends. I don't know off the top of my head. I know that there's a lot of pros and cons for using spine in Unity. The performance isn't necessarily the major pro that we are using spine in Unity for. It's more of the ease of access to rigging a 2D character that can use and share assets between each other. So again, for the spine characters that share a lot of assets, we can easily swap those as skins. I'm not sure if Unity can do that. I don't really mess with the Unity animator that much. So I don't know the inherent performance properties. Maybe DJ, if you have any thought about that. What we were talking about today at work was, memory impact on you, whether or not you're actually using assets. So like we could load in an entire character with a texture sheet, but it might not necessarily be using that entire texture sheet in memory if we're not pulling the PNGs from it. I'm not sure if, I think that's just more along the lines of Unity asset loading, but yeah.
You're getting how your assets are structured. So if you're just doing like regular PNG sequences, it's simple, it's fine and everything. But if you have like 1,000 PNGs for each animation or something,
Right.
Spine is going to be
way better. Yeah. Spine actually does have an option to export as a PNG sequence. It's not necessarily its forte, but yeah, like DJ said, if you're running a PNG sequence versus like a rigged skeleton, it's going to save you a whole lot. Because, yeah. Hey, Rob.
Hey, can you share the GitHub file there?
Yeah. I just threw this script together kind of quickly, but if you guys wanted to check it out, it's github.com/bdnhrsn. I will post this link on the Discord as soon as we get done. It's just a project, a Unity project. I'm using this in 2017, so the runtime, I think the Spine runtime is like anything past like 5.6, so you should be good if you're relatively up to date. So you can check that out. Inside of this repo, I'm just using assets from Spine examples. Like I said, they supply a lot of different examples over here, like all of these folders: dragon, soldiers, goblins, hero, which is subjective, raptor. Yeah, so again, I like Stretchy Man. Stretchy Man's cool. He's got a very good. Oh, here he comes. Oh, there he goes. Where's he gonna go? I think he has, and then he also has a sneak. So there's a whole bunch of examples that they kind of just that they provide. So it's really easy to get set up and messing around with that stuff. And that is all on that GitHub project as well. If you take a look at the archive for Noelle's workshop, I'm sure that she goes through creating like a simple skeleton, animating a couple things, and exporting it. You guys want to try stuff out, super easy. Suggest going back and looking at that. I think it's perfect for things like game jams because you don't typically have too many import issues with Spine in Unity. It's really easy to get a lot of assets quickly into Unity and immediately playing. And you don't need to worry too much, again, unless you're messing around with physics, about actually controlling a lot of this stuff in scenes. So it's very easy, quick to use. Any other questions? Yes? Oh, you're doing this. I see. Okay, cool. Thanks, guys.
Thanks, everybody. Remember game jam this weekend. Even if you're not going to make the game, just come hang out. Usually around like 6, 7 p.m. we'll be projecting video games playing us. So yeah, come hang out.